welcome back to Apply the Cometics class. So in this class, we want to continue the interpretation of the estimated linear regression model. So here we are still on a level, also known as linear model. So, but we are going to consider another case. In our last video, we considered a case whereby neither independent variable nor the independent variable is measured in percentage. Here, we want to shift by considering a case, that is case 2, whereby the independent variable is in percentage. Okay, so let me write the simple linear regression model. So we have beta naught plus beta 1, then beta 1 xi plus u. So this is our population regression model. So let's say we have our estimated regression model today like this. So we have a beta naught hat plus beta 1 hat, then we have x. So this is our estimated regression model. Okay, now how to interpret with case, let's say case 2, y here is measured in percentage, okay, but x is not, okay, it's not measured in percentage, it's in the original form, original unit, not measured in percentage. So how to interpret that? Okay, so we are going to consider the situation whereby our beta 1 hat is negative and also when it is positive. But before we do that, let's consider a general interpretation of this. The general interpretation of this will be that on average, okay, on average, a unit change in xi is associated with beta 1, which is beta 1 hat, percentage point change in y. So why is it not a unit? It is not a unit because this variable y is measured in percentage and it enters this regression model in percentage. Okay, and we know a change, that's a unit change in a variable that is measured in percentage, is known as percentage point. Let's say we have inflation and we have relation, let's say 3%, 4%, 5%. Okay, so the movement from 3% to 4% is known as 1 percentage point. Okay, 1%. So an increase in this percentage is known as 1 percentage point. Okay, so movement from 3% to 4%, we have a change in inflation rate from 3% to 4%. So it is called 1 percentage point. 1 percentage point, not 1 percentage change. 1 percentage point. That is why this interpretation is the correct one. So we will not interpret as percentage increase, percentage change is going to be interpreted as percentage point change. Okay, now let's consider a situation whereby we have, if our beta 1 hat is positive. Okay, if it is positive, how do we interpret? Very straightforward. So the interpretation is going to be that y is positively, because of the sign, related to x. Okay, so Another word, on average, because x is not measured in percentage, it's measured in its original unit. So on average, it's going to be a unit, that is 1 unit, increase in x is associated with beta 1 at percentage point increase in y. Why is this so? Because this coefficient is positive, and when coefficient is positive, it implies that y always move toward the direction of the change in x, okay, as explained in the previous video. Okay, so this is the interpretation, okay, and vice versa, because we are dealing with a vice versa, because we are dealing with a linear model. So vice versa here implies that unit decrease in x will be associated with beta 1 percentage point decrease in y. Okay, in other words, the summary of this is that when x here fall, okay, when x fall, so y will also fall, okay, by when x fall by one unit, okay, y will also fall by beta 1 at percentage point on average. So that is what vice versa is doing there. Okay, so let's consider a case where beta 1 at is negative, that is less than 0. Let's consider that case. So how do you interpret? It's very straightforward. So we are just going to change the direction of our initial interpretation. So the interpretation is going to go this way. Because it is negative, so it means that the dependent variable y will move in the direction of the change in x. Okay, now look at here, we have y is negatively related to x. Okay. So in other words, on average, a unit increase in x is associated with beta 1 at percentage point decrease, because it's going to be in opposite direction in y, and vice versa. So vice versa here implies that on average a unit decrease in x is associated with beta 1 at percentage point increase in y. Okay, that is what vice versa implies here. Okay, because we are dealing with a linear model, both interpretations are equivalent. So in the next